Norton's theorem states that Norton's theorem states that a linear two-terminal circuit can be replaced by equivalent circuit consisting of a current source IN in parallel with a resistance Rn, where IN is the short circuit current through the terminals and Rn is the input or equivalent resistance at the terminals when the independent sources are turned off. So the same statement, I think this last part can be is a different one, right? So compared to a Thevenin's theorem, what is the differences here? So the same statement we can write say for Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by equivalent circuit consisting of a voltage source VTH in parallel in series with a resistance RTH. Now what you are doing here, we are replacing with a current source, practical current source in general. But how did we calculate VTH? We calculated the VTH across the terminals AB, that is open circuit voltage. But when it comes for the Norton's theorem, or if you want to find the value of current, how can you find it? We can't find it in an open circuit. So what we have to do? We have to find the short circuit current, right? So we do short circuit now. Suppose if I have a complex network, right? Let me say that this is a complex network and I wish to find current through some resistor here, which I call it as RL, same as previous. So I want to find current here. So if I want to find the current here, this complex network has to be replaced with two element network. What is that element? One is current source, another one is resistance. So how do you calculate this value of current source? Is just by short circuiting these terminals. Previously we used to consider this as A, this as B, open JC, ikkada V, A, B find out chesavallam. Ippudu em chestamu? We will short the terminals and find the current that is flowing through them. So that is how we get the value of IN. And how do you see the value of RN? RN is almost equivalent just like RTH. What is RN? Is nothing but simply RTH. Since we are using it in the Norton's equivalent circuit, we are writing RN. If not, it's just not the procedure for finding the value of RN is similar to that of RTH. Am I clear with this? So what is the Norton's theorem? What is the Norton theorem states? The whole complex network can be replaced with two elements connected in parallel, or can be replaced with a practical current source. Let us see one by one what does it mean, right? So this is how we calculate. This is a complex network, right? So this is a complex network, and wherever we need to find, suppose say if I have a resistance here, we remove the resistance and we place a short circuit, and whatever the current that flows in this short circuit, right, will be considered as IN. And what's the value of IN can be given as is just VTH by RTH, or we can directly find the value of RTH. Okay. So let us take this as an example. Fine. So find the Norton's equivalent circuit of the circuit shown in the figure below. So what is the thing we have to find now? This is a complex circuit and already the resistance is removed here. If at all we want some resistance, I will draw some resistor here, and let us make the circuit complete. Let me take this as 10 ohms here. You consider this as I, and I want to find this as I, and consider this as RL, right? So now the question is complete that you need to find the value of current flowing through RL. So what has to be done first? What are the things we have to find? Rule number 12, what are the things we have to find? We found VTH and RTH in Thevenin's theorem, right? Similarly, what we have to find here?
IN.
Yeah, ISC, which is equal to IN. Right, this was VOC, right? That is open circuit voltage, or VAB. Whatever the value we write, open circuit voltage or AB voltage, that is equal to VThevenin, right? Now, how can we get the value of IN is by getting the short circuit current across this terminal. And what's the second one we need to find is RN. Is that all we want, right?
Yes, sir.
So first get me the value. I will tell how to find the value of IN. Just get me the value of RN. Get the Thevenin's equivalent resistance for this circuit. So this is called the command. What's the equivalent resistance? RTH.
4 ohms.
Yeah, it's 4 ohms, right? So how do you get 4 there? How do you get conclude to 4? Rn is equal to 4 ohms. So what is happening? This becomes open circuit. For finding equivalent resistance, the current source has to be replaced with open circuit and voltage sources are to be shorted, right? So this is open, so there is no current flowing here. So whatever the current comes here will be divided into these just like this. So these two are said to be connected in parallel, these two branches. So in this branch, what's the equivalent resistance you have? 8 plus 4 plus 8. You got it as 20. This has 5. So what's the equivalent resistance when 20 and 5 are in parallel? 20 parallel with 5. What do you get it as? 100 by 25. Get it as 4, right? So what's the equivalent Thevenin's resistance or Norton resistance? You can give it as 4 ohms. Am I clear? Now, how can you find the value of ISN then? What to do to find the value of ISN?
Sir, we can convert that voltage source into a current source.
Yeah, but what's the need?
And then we can sum up all the sources and then we can find current.
Yeah, is there any such need to find the such case, or you can directly let us convert them. Then that if that is the if you feel that that could be easier for you, then solve it. That will be fine, right? So you have a current source here, already 2 amps, right? So this is 2 amps, and what about this? If I convert this, you will get some equivalent like this, right? Is that okay?
Yes, sir.
4 ohms, and since we are short circuiting this, I think we can ignore this 5 ohms, right?
Yes, sir.
Why can we ignore this 5 ohms here? Because we know that current through a short circuit component is 0, right?
Current is 0. Yes, sir.
Yeah, so we can ignore it. So only elements that are present in the circuit are this now. 8, this has 8, this has 4 ohms, and what will the value of current here now?
60. No, wait. 48.
Why? V by R, na?
Oh, okay. Sorry, sir.
It is 3 amps.
3.
Is that okay?
Yes, sir.
Now we have to apply the current division here for this circuit, and let me know what's the value of current that flows here. Did everyone understand why we convert? What's the need for doing this? Is that okay if we convert a system like this, or you can also directly do it, no issues?
Sir, 5 ohm resistor will be included, no, sir?
See, if I include it here, what's that? What will be the value of current that flows in this resistor? No issues, man. Let us say, no need to go for generalizing. You just keep it there. Okay. Let the circuit, let the is my screen visible?
Yes, sir.
It's visible, right?
Yes, sir, it's visible.
Yeah. Now, keep the 5 ohms as it is and find the values of current that is flowing in these two elements. See, you'll get some value of current up to here, right? You find the value of current up to here. Is that okay? Can you find the value of current up to here?
Across A and B, sir, the same current will flow through the 5 ohm resistor also, sir.
Which?
The circuit is short circuited at A and B.
Yeah.
And opened at A and B, then the same current flowing through 8 ohm resistor will flow through 5 ohm resistor, no, sir.
If I open A and B, then it will flow through 5 ohms. But I'm shorting this, right? I want the short circuited current here, right? What is IN is the short circuited current when the terminals A and B are shorted. So what is the current that flows through 5 ohms when there is a short circuit across it?
Okay. It will be 0, sir.
Yeah, even if it is in the circuit, it will show no impact on the current that is flowing in the short circuit, right?
Yes, sir.
So that's the reason we can eliminate this. Even if it is in the circuit, while apply the current division rule here, we'll get the value of current to flowing through this resistor, this 5 ohms resistor as 0, because the value of resistance here is 0, right? What is the
Yes, sir.
resistance offered by the short circuit is 0, right?
0.
Am I clear with this, everyone?
Okay, sir.
What about others? Okay.
Yes, sir.
Fine. So now what you have to do is calculate the value of current that flows through this short circuit now. So I can make this a equivalent of 5 amps. What's the current source I have? 5 amps. Can I make it as 5 amp source? And I have a resistance here of 4 ohms and a resistance of 8 ohms here. I have a short circuit across A and B and one more 8 ohms here. So what's the current that flows in this path is important, right? Since this is in parallel, these all are in series, right? So since these all are in series here, what are the current that flows here will be flowing here that can be equated to IN or ISC, right? So what's the current that flows here and here? This is 4 ohms, this is 8 and 8, 16 ohms. So what's the current that flows here and here? Apply the current division rule.
1 amperes will get, sir. 1 ampere.
You'll get 1 ampere, right?
IN.
I take it as I1, this as I2. What's the value of I2 will be?
1 ampere.
I2 is
1
equal
ampere.
to, yeah, 5 into 4 by 16, right? No. Total resistance 20.
5 into 4 by 16 plus 4.
Yeah, 20. So you'll get it as 1 amp.
Yes.
So what's the equivalent IN can be written here as we can write the value of IN as 1 amp is equal to 1 amp. Right. So you got the two values, and what's the equivalent circuit that can be drawn as now? So we removed RL first for the finding the value of IN and RN. So we can reconstruct back it. We can construct back the circuit by these elements. Okay, with the equivalent circuit, what's the elements you have here is first I have a IN current source in parallel with RN, and where should I connect the value of this is terminal A, this is terminal B. So I can write this here RL. RL is equal to 10 ohms, right? So what is the value here now? What is the value here? RN is equal to this is IN, right? So what's the equation I can write for current IL now? IL is equal to IL is the current flowing through RL, right? Here. I assume this as IL. We are interested is to find I, right? So what's the equation for IL here now? What's the equation you can write for IL? IL is equal to same, apply the same current division rule. What happens? Total current, that is IN into opposite branch resistance by total resistance. RN plus RL. Right? So what's the value I get here?
0.285 will get, sir.
Yeah, 1 ampere into RN is we got it as 4 divided by 10 plus 4 plus 10. You get it as approximately
0.285.
285 amperes. So this is a value of IL that is flowing through the load resistance. So this is one of the method, right? So Norton's theorem is just a duality of Thevenin's where a practical voltage source is replaced with a practical current source in the equivalent circuit. That's it. Clear with this circuit? Clear with the theorem? Is it okay with the Norton's theorem now? So this is it, right? If you wish to solve the problems for this, all the circuit examples which you have done for Thevenin's can be also be used for this. Okay, we can replace the Thevenin's equivalent with the Norton's equivalent circuit. Shall we go for the next maximum power transfer theorem? Rule number 12.
Yes, sir. No problem.
Yeah. Is that okay with this?
Yes, yes, sir.
Fine. Now let us go for the maximum power transfer theorem. See, we have a theorem which defines or which is defined based on the circuit characteristics, right? In many times, or I think you have come across some electronic circuits where you see some resistors, inductors, capacitors, which yeah, which
LCR circuit, sir. LCR circuit.
yeah, whatever circuits, series RLC circuits, all the time it's not mandatory to use all the three elements, but many a times we can see some resistance, see with some color codings, the resistors which you see in the lab, right? We can see them on circuits where you have, suppose if you have a remote control at your home, right, or a small PC board where you can see numerous values of resistors. And sometimes we use resistors not only to dissipate the power. You know that resistors are not good sources. What's say? Not they will not be storing the energy. They are just dissipate the power, right? Resistors dissipate the power in terms of heat. We already studied this, right?
Yes,
But
sir.
what is the need for using so many of elements then? See, uh, for we know that for doing some work we require some power, no doubt, but uh, when it comes for the electronic circuits, we can define what is the power that it can deliver, or say uh, what is the amount of power that we can give it for any particular element, right? So when it comes for maximum power transfer theorem, maximum power transfer theorem is generally employed in electronic circuits where the power transfer to the circuit can be made maximum. Okay, we can define the what is the amount of power that can be made to flow through to the circuit by defining the resistance. So it is observed that suppose say I let me consider this as a example now. See, if I have a circuit like this, right? I have a circuit. Let me consider this whole circuit as a complex network, right? Just like previous examples, let me take this as a complex network, right? And this has a load resistance. I want this. Let me take this as one of the element which is in which the work has to be done. Let us say if this is a immersion heater, if this is the resistance there. Okay, I'm just considering an example. That's it. Suppose if this is a resistive element in that coil which has to produce a heat. Now, what should be the value of this equivalent circuit or this complex network to have to deliver more power at this RL? Does this resistance have impact on the power that is delivered to RL? There will be definitely some impact of this circuit resistance on the amount of power that is delivered to this RL. So when will be that power be maximum? In general, is that we do certain calculations, and this power maximum power transfer theorem states that the power transferred to the load resistance RL will be maximum when VTH is equal to RL. Or sorry, RTH is equal to RL. So at this condition, that is, at this if this condition is satisfied, right, the power delivered to the resistor will be maximum at this condition. Are you able to understand? If the resistance of the complex network is made equal to the resistance of this RL, right? Then we can say that, right? If this is network resistance, right? I define this with some other value, RTH, equivalent resistance, right? If these are equal, RTH is equal, made equal to RL, then maximum amount of power can be transferred from the source to load. Right, this is the load, right? So maximum amount of power can be transferred to the load when the external resistance, that is load resistance, is made equal to the Thevenin's resistance. We can calculate this, and this is a proved theorem. Am I clear? So what is the statement for a maximum power transfer theorem? Maximum power transfer theorem states that the power delivered to the load resistance will be maximum when the equivalent resistance of the circuit is equal to load resistance. Equivalent resistance is equal to load resistance. That's what is defined here, right? So this is how the statement is. What is that value of resistance that what is the condition we derive is this. We'll derive this condition, no doubt, no problem, fine. But what is the condition we are arriving at? What is the statement is based upon on what equation the statement is based on? Is on this. RL is equal to RTH, right? And what is the maximum power equation for maximum power that can be delivered is given as VTH squared by 4 RTH. Okay, so we will derive this equation, no doubt, fine. But one second. So first, before that, you write the statement for the maximum power transfer theorem. Yeah. So what is you write this statement first. We'll let us solve derive the equation here. That will be fine. So what is the statement? What is the theorem? Maximum power transfer theorem. CR?
Yes, sir.
Is it possible to observe who is changing this or who is coming the sounds? I haven't faced problem till now, but today is the day one, right? So keep an eye on the people who are making sound in the participants list, okay? Is that okay?
Okay, sir.
Fine. Yeah. So what's the equation that can be given for any no doubt this is a Thevenin's equivalent circuit, right? So maximum power transfer theorem, we are employing the Thevenin's equivalent circuit, and based on the Thevenin's equivalent circuit, what's the equation I can give for I? What's the I is the current flowing through the load. So what's the equation I can give for I? I can be given as VTH by RTH plus RL, right? Amperes. So now, whenever it comes for a power, what's the equation for power given as? P is equal to VI, or we can write it as I square R or V square by R, right? So let us take this equation for power, that is P can be given as I square into RL, right? So all we are trying, why we need power is because the theorem itself is based on the maximum power, amount of power that is being transferred. So we take P is equal to I square RL, where I can substitute the equation for I as VTH by RTH plus RL. So this is the equation I am going to get. Fine. So what is the next step of equation can be expanded as VTH square by RTH plus RL, RTH by RL whole square into RL. Then after this, is that okay? Or else I can keep the same as this is as it is, and when you are going to define the values of maximum or at a point or a value, what can be done?
Differentiating.
Yeah, differentiate it with respect to a variable.
Equate it to 0.
And equate it to 0. So what is the variable we have is the load resistance, right? What is the variable I have? Is the load resistance. So consider this equation P is equal to VTH square by RTH L plus L square into RL, and differentiate it with respect to RL and equate it to 0, and tell me the equation.
Sir, once can you repeat why did we differentiate?
So what's the need for differentiation?
Sir, I didn't get you. The
Yeah,
voice
yeah.
cracked or something.
Yeah. See, whenever in mathematics in general, whenever we wish to find any maximum at of a value or a point, right? What we generally do is differentiate that equation with respect to some variable in the equation. Yeah, and
Yes, sir,
equate
yes,
it to
sir.
0.
Okay, we are
That will,
we're to find
that will,
maxima.
yeah, that will give the condition for that maximum.
Sir, I understood. I didn't hear the maxima word.
Yeah. That you will get the condition for the maximum. So what you do now is write the differentiate this equation with respect to RL. Have the equation, right? P is equal to we have the equation for P. What is that? VTH by RTH plus RL whole square into RL is the equation, right? Now use this in place of P and differentiate this whole equation with respect to RL and equate it to 0 and tell me the condition which you get there. I already have the equation. I already shown you. You just give a try. What is the next step could be? If I do this, what is the tell me what type of what equations you are supposed to use for deriving this? So what will be the equation here after d pi by d by RL of? Can I use a single term this as VTH or can shall we use as different terms? VTH square RTH plus RL whole square into RL, right? So what happens if we differentiate this with respect to RL? What you are going to get? I think VTH is a constant. So I think we can bring this out, right? VTH square. So I can take it as RL by RTH plus RL whole square is equal to 0. What's the type of differentiation you use there?
U by V differentiation.
Yeah. You can
UV,
use
sir.
UV, right? UV or UIV?
UV,
U
sir.
by V, sir. U by V.
Both are different, right? UV and UIV.
Yes, sir.
Yes. Sir, U by V, because in both numerator and denominator are the same variable.
Yeah, we have the same variable. Right. So use that and get me the equation for condition for maximum power. So now you connect. You're having this R, right? Connect these two display. Can I expect some answer? Current measurement along with this display.
1 minute, sir, doing.
Okay. Now connect this I to what display. So that now these two components together you will get the ammeter. And this ammeter having positive terminal, that's having the negative terminal. Okay. So now in the circuit, positive terminal is connected with voltage source, negative terminal is connected with the resistor. So connect this positive terminal. Positive terminal to the negative terminal to the resistor.
We get RTH is equal to RL, same, sir.
What's the answer? What's the equation you got?
Same, sir.
This is similar to this.
VTH square by 4 RTH. We have to substitute that RL is equal to RTH.
You just get this value, right? RL is equal to RTH, you will get it from
Yes,
the
sir.
derivation. If you equate it to 0, right?
Yes.
Yeah, substituting that in the equation, previous equation where we use that P is equal to, what is the equation we were writing? We wrote a first
VTH by
equation.
RTH
Yeah,
plus
VTH
RL
square
whole
by RTH
RTH
plus
plus RL
RL
whole
into
square.
whole
Whole
square into
square, sir.
RU.
Total whole square into RL.
Yeah. So what is the equation we can get? Is substitute that VTH is equal to RTH. You will get it as 2 RTH whole square, right? Into RL, or else RL into this. So what's the value you are going to get? This as RTH, this as RTH. So you get it as VTH square by 4 RTH square into RTH. So square and this get cancels. So you get it as VTH square by 4 RTH. So this is how you get the value of maximum power, right? So for a circuit, right, for a circuit, if at all you want to get a maximum power to be delivered to the load, first condition is this, is that RTH should be made equal to RL. And what's the second condition? What is the second what's the value? What is the value of that maximum power? Is given as VTH square by 4 RTH. Am I clear with this?
Yes.
Yeah.
Yes, sir.
So yeah. Let us solve a problem for this. Let us see whether we can find the maximum power. Yeah, you can post your details. If at all you want something, you can post in the chat box, right? Okay, find the value of RL for the maximum power transfer in the circuit of figure. Find the maximum power. Just solve it and tell me the value of maximum power. So what is the first thing you need to find is to find VTH and RTH first, right? What's the first thing we have to do is to find the value of VTH and RTH, connect the equivalent circuit, right?
RTH equal to 9 ohms.
RTH is equal to
9 ohms.
9 ohms.
VTH equals to 16 volts.
Okay. VTH is equal to
16 volts.
16. Okay. Get me the values VTH and RTH. Did everyone get the same values? What is the value? Tell me again. VTH is VTH is
1 minute, sir.
16 volts.
16. Okay.
Right here, I already created a file once on the desktop. I can open it directly. So, but on this screen, I have go to library. Instead, go systems, specific technology, fundamental law, fundamental source, this voltage source.
VTH is 22. RTH is 9. VTH is 22.
Then go back and go to the elements. Branch is IC branch. Click on this. Select only resistor. So resistor value 1000 ohms. Click the controller to protect this. So this 4 PS.
So what's the maximum power transferred or maximum power that can be transferred is 13.44 watts.
What resistance are. Now, how you can take the ammeter here? As I said before, you will not have the ammeter directly here. So instead of that, you have a current measurement. Go to the measurement curve and take the current measurement. Okay. Now, if you see here, current measurement curve, you can observe plus sign here, minus sign here, and the I symbol with some arrow indicated like this. Okay, this one. Okay. So now this arrow you have to connect with the display. Okay. So go to library.
Sir, once can you show that RTH page?
Since you may be having this display.
This
This current measurement curve. Now if you connect this I to this display,
Okay, sir.
now this is together will act as
okay.
ammeter. Okay. Okay. So these names also you can change. This current I. So this current measurement along with the display.
Is that okay with equations?
Yes, sir.
Yes, sir, done.
Yeah. So this is what we can derive. See, we also have this theorem in our laboratory, so we can. What will happen if I'm getting VTH, say maximum power at when RL is equal to RTH? What happens to the value of power that if the value of RL is beyond RTH? The amount of
It decreases steadily.
yeah, the power transferred to the load will decrease actually.
First it increases, then when RTH is equal to RL, it's the maximum.
Maximum, yeah. And now it comes to the RL, right? So this is a reminder, if given a chance or if we will get a chance to do the practical experiment, we can derive or see whether they are changing it accordingly or not, right? Right. So let us go for the next theorem. We finish Thevenin's, we finish Norton's, we are left with reciprocity. We have only 5 theorems, right?
Wait, I will take another question.
So next comes the reciprocity theorem. Fine. So what does it mean by reciprocity theorem? What does the statement mean? The reciprocity theorem states that in a linear bilateral network, if a voltage source V in a branch A produces current I in another branch B, then the same voltage source V acting in branch B would produce the same current I in branch A. That is, if the suppose say if I have a network of this type, right? Let me show you. One second. Yeah. See here. Suppose if I have this type of circuit, I said that if
मेरी लाभ है ना
2 hours class. Suppose
एक सब्जेक्ट का करना
yeah. So if this is a branch, let me say that this is one of the branch where I have the source, right? Is it visible, right? My screen is visible, right?
Yes, sir.
Yeah. So if this is considered as branch A, and if this is the response of current due to voltage source in branch A, let this be considered as branch B. So you consider this as excitation, or you call it as source or excitation, and this I consider it as response. So what do you mean excitation is just like source, response is the output, right? So I have a voltage source here, and the response of this voltage source, if I measure here, is the current. Reciprocity theorem states that even if I interchange these two, that is, if I replace this voltage source here, and that is, if the excitation and response are interchanged, then the circuit remains same, or the values remain same. That means if say due to this voltage 36 volts, if I am able to get a current here as 10 amperes, right? If I replace them or if I interchange them, that means if I keep the voltage here in this branch, which is 36 volts, right? I should get a current here in this branch as I as 10 amperes. That's what the statement means. I mean, are you able to understand? Reciprocity theorem says that even if I interchange the excitation to the response, the ratio of this remains same. That is, and let me give the definition once again. I think it will be clear for you now if I read it again. Right? Yeah. So what does the statement mean? In a linear bilateral network, if a voltage source V in a branch A produces a current I in another branch B, that is, voltage in branch A produces a current I in another branch B, the same voltage V acting in branch B will produce the same current I in branch A. That is, the ratio of response to excitation is same for the two conditions mentioned above. Is called the reciprocity. Am I clear? The ratio of response, that means the values of voltage and current remain same whether they are even they are interchanged. So the ratio of V by I is known as transfer resistance. This would be same. This would be same in both above mentioned cases. In both cases, the value of V by I ratio should remain same. Am I clear with the statement? Someone there?
Yes, sir.
Yeah. So what we are doing here, or what you are trying to learn here is the reciprocity. What does it mean by reciprocity? Is that the ratio of response to excitation when they are even interchanged should remain same. Then you call it as a reciprocal network, right? So let us consider one example and see whether the circuit becomes reciprocal or not. See, we'll consider the same example which I give you. See, so what has to be done here in this circuit now? Verify. Let's verify that by considering this example. In the network shown, find the current in branch B due to voltage source of 36 volts in branch A. Now transfer, what this is the steps we have to do, right? Now transfer the voltage source to branch B and find the current in branch A. Also determine the transfer resistance from branch A to branch B. So let me, see here. First, what we do is we consider the circuit like this. This is a circuit, man. Okay, take down the circuit first. You just divide your page into two, and on one side of your page you just draw this. Okay, one side of the page you just draw this circuit. On the other side, I will show the another circuit to draw. It's a simple circuit. You just draw it, right? Right? Finished. In the next circuit, or in the other side, on the other side, you just draw the circuit. On the other side, you just draw the circuit.
Once can you show the values for the first resistor, sir? Circuit, sorry.
Values remain same.
Yeah,
All the
okay.
values are same. Okay, is this visible?
Yes, sir.
Two circuits.
Yes, sir.
Yeah. Now, what the reciprocity mean is that what we do here, we will find ultimately what has to be done is to find the value of current here. Yeah, by some methods which you learned, nodal analysis or mesh analysis, right? We can get the value of now. How do you find the value of current? What is the methods you are using? to find the current? What's the best method to use to find the value of current?
Thevenin's
Use
theorem.
Thevenin's?
Theorem, sir. Network theorem.
Yeah, Thevenin's theorem. Is it
Thevenin's.
fine?
Yes.
Okay. So what's the equations you're writing? What's the value for VTH you're getting? VTH is equal to, what's the equation we can find? How can you write the value of VTH? I think once you open this will be the circuit, right? This will be the only loop I have, I. So what's the equation you can write for VTH? Is the voltage drop across 12 into I, right? 12 into I, right? Is that okay?
Yes, sir.
Now what's the value of I now you can write? I is equal to, what's the equation you can write? 36 divided by 4 plus 2 plus 12. Is that okay?
Yes, sir.
What's the value I'm going to get here? It's 2 amps, right?
2, sir.
Yeah. So what's the value of VTH going to be? 24 volts, right?
24 volt.
Yeah. So what's the value of RTH going to be? RTH
9
is equal
ohms.
to,
9 ohms.
9
yeah,
ohms.
these two are in series. 2 plus 4 is in series. 6 and 12 will be in parallel. So what's the equation equivalent for 6 parallel with 12? 3? 4? Okay. 4 in addition with 3. What's the value you are going to get for this? Is it 7 ohms or what's the
Sir,
equivalent for
that is
6?
4, sir. That one 3 plus 1 are in series.
No. Forget about this one. This is already removed, right? This is RL. These are the terminals A and B,
Okay.
right?
Yes, sir. Yes, sir.
Yeah, this is already removed. So only the elements we have is these two. 6 parallel 12. What's the value? 6 into 12 by 18. 4, right?
Yes, sir.
So 4 plus 3, you get it as 7 ohms, right? Is that fine? So you have any doubt with that?
No, sir.
Yeah. So this is a resistance, this is a voltage source, and what is the RL value? 1 ohm, right? What's the value here?
1 ohm, sir.
It was 1 ohm, right? Okay.
How to do it on
1 ohm. This is 4 ohms. Sorry, 7 ohms. This is 7 ohms, and this is
24.
24 volts. So what's the value of IL will be? I is equal to, I write it as I1, right? I1 is equal to 24 by 8. 3 amps.
So here,
Is it okay?
you to log in first. Okay. I already logged in here with my name.
You got the value of, what's the value
Yes,
of current
sir.
you are going to get?
So I will sign up first.
3 amps.
3 amperes, right?
First go to and login.
Yes, sir.
So here you will get this window. Now start using MATLAB.
Okay. Now what has to be done? We found the value of current here, right? Similarly, we find the current here as well.
So then it is
So what is the, we'll apply the same principle here. So what is the value of VTH going to be here? VTH is equal
type
to,
your mail. First you have to register. I already registered MATLAB. So I'm directly
so now this will be RL, right?
you are not having the account. Okay.
Isn't it?
It will be 4 ohms.
Yeah, this will be RL now. Now this will be terminals A and B. So what's the value of VTH we are going to get here? How can you calculate the value of current? It's just like this, right? This is I. So similar to the previous case, what you are going to get here is the value of VTH is equal to 12 into I, right? So what's the value of I gonna be? It's 36 divided by 3 plus 12 plus 1. What's the value you are going to get here? 2.25. Yeah, 36 divided by, what's the value? 15, 16, right? 2 point?
So in the last
2.25.
65.
25.
2.25 amperes, right?
Okay, once you open the matter,
Now,
actually,
so
you
substitute
get
that
this,
here, what's the value you are going to get?
this
VTH,
is the icon here.
12 into
Yeah,
2.25.
this is already matter software is there. Now, you
24.
matter
Huh?
27.
and open it, you get this.
27.
And this window,
20?
it is
27, sir.
27.
27 volts, right?
So it is on the browser.
Now, what is the value of RTH
So you
going to
don't
be?
need to install this matter.
So this is open circuited, these are shorted. So these two are in series, 4 in
Now here also you have
parallel with 12, 4 into 12
5,
by
sir,
4
5.
plus.
flip colors.
RTH is
5.
sir.
5 ohms, right? Therefore, what's the equivalent circuit should be, how the equivalent circuit will be like this, right? Fine. What is this value? 5 ohms. This as RL was 4 and the voltage is 27 volts, right? So what is the value of I gonna be?
3 amperes.
2,
Amperes, sir,
27
yeah.
by 5 plus 4, you are going to get it as 3 amperes.
3 amperes.
See, the values of VTH and RTH are not same, but at last the value of I1 is equal to the value of I2. So the reciprocity theorem states that the ratio of V1 by I1, what is that V1 by I1? 36 by 3 is equivalent to V2 by I2. What is that? 36 by 3. Hence, prove the reciprocal property of the network, right?
Here also you are getting almost all the-
So what are you trying to prove here?
So you need what you need to go? You need to go to Inkscape, right? So here you are-
Since it's a linear bilateral network, the characteristic of the response to excitation, the ratio of excitation to response is not going to change.
Actually, here power system here it is on.
Am I clear with this example?
Yes, sir.
All the linear networks are reciprocal, possess the reciprocal property. But this is a very fundamental actually. But as we go into deeper into electrical circuits, we have some other elements where we can apply this reciprocal property, reciprocity property as well. So, but for our understanding in BWE, that I think this is enough. So we can find the
Specialized power system.
would say we can
Now here we will be having the power
see whether the network is reciprocal or not. And most of the times, until unless we have
this we keep it as
residual elements, as long as you have residual elements, the circuits are said to be having or said to be reciprocal in nature. And we have some extension for this network analysis. In network analysis, we will be studying something like, I think you heard about some derivation.
here we have
Have you heard about something called as AD minus BC? I think you heard that in matrix forms, right?
Sir, AD minus BC in what context?
Yeah. And that's I think you haven't heard that actually. We have some parameters for networks, ABCD parameters. So we'll define the value for every network. We'll define the values of ABCD, and if the condition satisfies AD minus BC, right? Then we call that the circuit to be reciprocal in nature, actually. But that is not written. That is in the context of two-port network. So every network.
Sir,
So
what network?
yeah, two-port network. Two-port network.
Yes, sir.
Yeah. So see, we are considering these terminals as AB as output, right? So we can even consider these two terminals as inputs, right? If suppose say I can consider these to be C and D, right? What are these terminals called as? C and D are called as input terminals and A and B are termed as output terminals. So as a whole, I can give this whole network to be a two-port network like this. That is two input terminals and two output terminals. Okay, input, I said output as AB, input as CD. So this is a two-port network actually. So for every two-port network, we can define whether the circuit is reciprocal or not by using the conditions. Let it be, it's not up to for us, but just to know the values, fine. So I will try to share notes for the theorems, and I will also send some let's say numerical problems or exercise problems. Fine. Many of your friends are responding. I think almost I receive 7 to 8 responses every day on the questions. Fine. So let me see whether there should we do video or audio for TikToks. So what's the problem with your TikTok, man? What's the problem you're facing for TikTok?
Sir, video also should be there.
Yes.
Then how do you do that? Actually, what you're doing?
Sir, I already did and submitted, sir. My videos are not there.
Yeah. Let me ask something. What the concept? What is the reason for having a TikTok video? What's the intention of having that?
For us to understand what topics are.
Yeah, and we has to see how you are delivering it, right?
Expressing the topic.
Yeah, what you need to search, you need to go through the internet sources where you can find the topic and information related to the topic. Okay, and we want you to express your view on that. That's it. We're not here to say.
Sir, I've already submitted it without video.
Yeah. See, it depends on the faculty who is evaluating it, right? But the procedure, I want to tell the procedure how it has to be done and why it is to be being done, right? So TikTok concept videos are just to make you search or go through the resources which you have and learn something and prepare something by your own. So how it is very easy to add audio, video, and PPT at once because you have Zoom apps, right?
Okay, web browser లో ఓపెన్ చేసేప్పుడు వచ్చింది కదా.
You have Zoom app, right? Yeah. So you can prepare the
Actually
PPTs
మనం ఇక్కడ
of 5 or 6 slides
సాఫ్ట్వేర్ యూజ్ చేసి ఓపెన్ చేస్తే
and you can record the video in the Zoom itself and upload the same. That will be fine, right? How did you people do?
Sir,
How
I
did you-
recorded my audio over the
Record.
presentation and uploaded it.
Yeah, you run the PPT, you added the audio for that and you just uploaded it, right?
Yes, sir. And some editing wherever parts went wrong.
If you send me that file to your friend, he can also upload the same thing, right?
But my voice will be there, no, sir, distinct.
Yeah, topic will be there and audio will be there, but we need to open it and see it, right? Whether it is yours or others. So all we want was you to deliver. So we don't want some investigation to be done whether it was done by you or not, right?
Sir, I have a doubt, sir.
Yeah.
Sir, can we on video for some time and just for like 4 to 5 minutes and later like we can off it, sir?
Yeah, everything is fine, man. If you are genuine to your topic and you see your work and your task, then that's fine. No one is going to question you. But problem is that what's the need for you to choose such difficult task or difficult way of recording it?
Like the video is like stopping in the middle, like it's coming like the lag is lagging in the middle, sir.
Yeah. So better, what's the best way to do is you know how to record a video in Zoom, right?
Yes, sir.
That will be very fine, right? You can take a laptop, you can present login to your Zoom ID. You start recording there, share your screen, present the PPT, and go on presenting it. It will record your PPT, it will record your audio, video. Then you can get the video and upload it. Then what's the bigger deal in that?
Okay, sir.
Some people are saying that sir, they have recorded the video first and they did the PPT with audio, they mixed them both. I don't know. I don't know how they are going to use this advanced technology. Is it that big deal to use all this? We made it very clear or very easy for you to do, right? But you are choosing different difficult paths. No issues. This is only first time, right? You will get used to that because you are going to do this for next 4 years as well. Is that okay?
After some time, you will get a value here.
Yes, sir.
Yeah.
1 million.
So
instead of that, you are getting 0.00.
we have
Sir, what about question bank?
Yeah, question bank. See, there are some. We have uploaded that to LMS, but the people in the say collected dean has suggested some changes to be done for the existing one. So the course coordinator, Sarath Kumar madam is a course coordinator for BEE. So ma'am is preparing or editing, updating that question bank. So we requested ma'am to update it as soon as possible, and as soon as we receive that, I will forward in the group. Is that okay?
Okay, sir.
Yeah, I will. I have also asked ma'am to speak personally to update it fast. What are the faster pace she can do? So she also said that once she get finished, she will forward us. Okay.
Okay, sir.
Fine. Anything else from the theorems? I will forward the notes. See the material just like for the unit one. I will forward the material for theorems as well, but give me 1-2 days of time. I'll do it. Okay. Is that okay for today?
Yes.
Yeah, fine. Then see you tomorrow in the first hour tomorrow. Thank you, everyone.
Okay. So like this, you can
Thank
type
you.
the voltage and you can note down the current.
Thank you, sir.
Right. So now, you go for KVL or KCL.